Awesome. And batting cleanup, ladies and gentlemen, we have, of course, if you're familiar with Portland, Portland is lucky enough to have 3 golf courses in town. And with me right now is going to cover that irrigation on the golf courses is Mr. Peter Gorman. So.
Perfect. Well, thank you very much. I appreciate the opportunity to come and speak to everybody today. See a lot of familiar faces in the room. Whenever I go to a water event, people look at me, and I'm kind of known as the golf guy. When I go to a golf event, guys look at me and I'm the water guy. Maybe that's just because I was foolish enough to show up the first time. I'm not sure, but kind of falls under that never do a bad job well type of a philosophy. So I put together about a 20-minute presentation, and the little monitor here says I got 7 minutes. So we're going to blow through this, and I'm going to skip a lot of the technical jargon. Some of it was already covered, so you're welcome on that one. So one of the first things I wanted to address is the public perception of water use on golf courses. So quick show of hands, when you think of golf courses, how many people in the room think of big, powerful sprinklers irrigating hundreds of acres of lush green turf? All right? Excellent. How many people think that golf irrigation use is a luxury consumption of a precious water resource? Fewer hands. All right, I like that. We're getting there. So what I want to do today is kind of go through the nature of golf course water use kind of from a 30,000 foot elevation kind of a perspective and narrow it down to exactly how is what the decision made to use water and how is it actually applied to the golf course. So this is a picture of the 15th hole over at TPC River Highlands. One of the misconceptions about golf is that we are trying to produce lush green turf. Actually, golf is designed to play on firm, dry surfaces, and healthy turf. Turf is healthier under a drought, semi-drought condition. If we overwater and over-fertilize, we end up running the risk of disease and poor playing surfaces, and it ends up costing us actually more money to maintain the turf. So go through a couple quick concepts here. So we've got evapotranspiration, demand. So that's the demand side. We talked about that a little bit already. And then the other concept is distribution, uniformity, and precipitation rate. So how is the water delivered to the turf and how much control do we have over that water going out? So there's 2 main components of a golf course irrigation system. The delivery system includes the pump, the piping, wiring, sprinklers, nozzles, hoses. How is the water actually put out on the golf course? And then the most important part is the control system. So we've got a central computer in most offices, field controllers out on the golf course that take the signal from the office, send it out to the individual sprinklers, and tell the sprinklers to turn on. And then we have remote controllers, whether it's a radio, now you can use your mobile phone, tablets, and all that's controlled via the internet. The delivery system, again, we've got pumps with energy and water conservation methods built into those. We got the new technology includes variable frequency drives that instead of the pumps turning on and just driving 100% full force all the time, it can sense how much demand is actually needed. So that conserves a lot of energy and puts a lot less wear and tear on the irrigation system and minimizes energy loss due to friction in the plumbing system. So the superintendent's job, we spend about 80% of our time trying to decide where water goes, where it's needed, where it's not needed, and how can we save water and control its application most efficiently. So I mentioned most of the superintendent's offices have computers that are designed to run the irrigation system. Software costs about $10,000 for each office, and the software determines the most effective way to deliver the water. The superintendent's job is to figure out, is water needed, how much is needed, and where is it needed? So the daily decision making, we have new technology that has become popular over the last few years where we use TDR meters, and these are probes that we stick into the green. So this little green probe that you see the gentleman using here, you put it in the green and it can measure the water content in the soil, the salinity, temperature, all that information, and it gets sent via Bluetooth to his cell phone. And that's also GPS connected. So he can go around and spatially figure out where the water is on a given playing surface, send it back to his office, map it out, and give it to his crew to go out and say, okay, this is the threshold, these are the areas that need to be watered. Instead of just turning on the sprinklers over the head, now we can go out with hoses and spot treat small areas about the size of your table and really control the irrigation efficiently. The other device gets implanted in the ground, and that sends a signal to the irrigation central control system. So that gives you the same information for an exact location over time. So that's the same monitoring the same location, all that information, and the other tool, you can kind of take it around the golf course. Daily decision making, the superintendents check the weather on average 10 times a day. I right now have 4 weather apps and 2 radar apps on my phone. When I was managing a golf course down in Brantford and I had the new irrigation software, I could watch, and based on the weather station that was outside my office, the weather station sent me a signal. I was watching the radar. I watched the storm go through. My weather station sent me a signal to my phone saying that we had gotten over a tenth of an inch of rain, and I pulled my app out and I turned my irrigation system off for the night, saving 120,000 gallons of water. So we can do that on a daily basis. The other thing that I had was I would get an email twice a day from the Northeast Regional Climate Center giving me the ET, the demand for the turf from 2 different radar stations, or 2 different airports within 20 miles of my golf course. And they sent me that twice a day, once at 3:30 in the morning, once at 5:30 in the afternoon. And what that did is it allowed me to have a baseline of, okay, what's the demand across in the area, and then I could go out on the golf course and see what the turf was telling me as far as how much water was needed, and I could adjust my decisions that way. Here's a superintendent out with a tablet, and he's going out and looking at the areas of the golf course. Wet areas, he's turning the water down. Dry areas, he can turn the water up, and he can do that on a head-by-head basis. So the irrigation database knows exactly what type of sprinkler is in what location and what type of nozzle and how much water that sprinkler head will deliver per minute. The programs determine, am I going to water the greens, the tees, the fairways, which hole am I going to water, how long am I going to water it for, and basically instead of saying I'm going to run it for 10 minutes, it says I'm going to put out 1/10 of an inch of water, and it adjusts based on the type of sprinkler and how much water that sprinkler can deliver. The other thing you can do is it can adjust for slopes. You can adjust how much time each sprinkler gets and how long they run for. Daily observations, spend a lot of time going out, checking, making sure the water's delivered the way we want to, and it's giving us the results we're looking for. And we spend a lot of time checking for leaks. So I'm going to focus on conservation for a little bit real quick. A big trend right now is to reduce the irrigated acreage. So courses are putting in a lot of native areas, taking sprinklers out. We're using more drought-tolerant grasses and designing aeration programs to maximize infiltration and retention of water once it hits the ground. As mentioned, I'm working with best management practices at the national and local levels. Connecticut has best management practices for water use on golf courses, and we're taking that to a comprehensive level with pesticide management, surface water management, water quality, IPM, pollinator protection. We have 12 different chapters that we're working on. The USGA has some tools out that we have at our disposal. They have a water budget calculator. They have a drought emergency plan. And water use efficiency guidelines. These are all templates that you can go online. We're going to include those in our BMP packages. And this is a really exciting one. So the turf breeders out in Oregon have come together to work with universities across the nation to develop the Alliance for Low Input and Sustainable Turf. And essentially what they're doing is they're trying to bring to market grasses that perform well under reduced irrigation and reduced fertility input, which I think is really important. And this is all just voluntary. It's driven by the industry, nothing mandated. So finally, I just want to wrap up this. That actually looks better up there than it does on the computer. So just want to change our perspective about golf and water. This is an aerial photograph off of Google Earth of Canton Public Golf Course in 1991. That golf course took up 70 acres, which provided habitat, water infiltration, and groundwater recharge. That's what that looks like today. So the golf course sold out. The family sold the golf course, and now it's a retail development that has 35 acres of rooftop impervious surfaces and accelerated runoff. The average golf course is a golf course in West Hartford. 18-hole golf course is about 100 to 150 acres in size. Only about 40% of that is covered by irrigation. The remaining area is woodlands, wetlands, native areas, and surface water. And based on, I did some quick back-of-the-envelope calculations, based on average annual precipitation, average ET over the course of the season, water demand for the season for this area, there's about a net input of 40 to 60 million gallons per 100 acres on golf courses in Connecticut. So everybody, thinks that we're just sitting there consuming a bunch of water and using up a valuable resource. We're actually putting in more water than we're consuming. And research actually shows that water leaving a golf course is cleaner than when it enters, because turf systems are the most efficient filters of water and precipitation in the environment. So with that, thank you very much. Just want to remind everybody, right across the river, we have the Travelers going on. I encourage everybody to participate. It's a great tournament. The organization is doing a great job. And last year, they generated over $2 million for 150 charities right here in Connecticut. So this is our tournament. I think it's the best sporting event we've got in Connecticut. And just one example of what golf does for the economy. Thank you very much.
Peter, do you think the superintendents over in Cromwell were watching radar this morning? Yes, ladies and gentlemen, Mr. Peter Gorman, okay, Mr. Mike Emmons, Mr. Tom Marmelstein. Again, I think it changes everybody's perspective, and that's one of the beauty parts of, the members of our committee and the participants. We're bringing everybody into the tent, and it certainly is an educational process for everybody. So at that point, we're going to take a break, or take time, and we'll be back with some more of our power panel. Thank you so much. So grab some coffee, grab some Danish, and we'll convene back here in, 10 minutes? Okay, thank you.